All right, welcome to class. Can you all hear me on the code?
Yes, sir.
All right, great. You all have two screens. Can you see my laptop and me?
Yes, sir.
Awesome.
The projector's not working.
Which projector?
Ours, we're not seeing, we only see you.
Okay, so you do not see the. You don't see my screen. Like there should be a feed that's just my screen. Probably a little more important for this class than most other classes. Is it just not turned on?
Well, it's on. Yeah. Are you sharing?
Maybe that's it.
If not, I can grab one of the iTech guys.
Okay, does that now I'm sharing.
Yeah, that is it.
Awesome. Okay, great. Thank you. Got to remember to share. It's always good to share.
It's up to y'all.
Okay, so this class is called Spatial Programming and Automation. So in this class, we're going to learn how to use a programming language called Python. We're going to spend the first 4 weeks just kind of learning the mechanics of the language itself, and then we're going to apply that to spatial GIS operations, basically. This course will mostly focus on using it with ArcGIS, but I'll throw in some examples from like open source software packages. There will be a Canvas site for this program. Does anybody see any of these 468s or no?
I've got my Canvas pulled up, and I don't see 468.
Okay, yeah.
I see it on there, but it's not published.
Okay.
I think I go to the all courses tab.
What do you see when you go to the All Courses tab? Does it show this, or does it have a cross list?
It just says
468.
yeah,
Okay. So she's going to combine the specialist that does this is going to combine all of my 468. She already did it once, but it just disappeared. So we'll all have one button that'll say like cross list spring 2018, and it'll be the lecture and the lab. So you won't have to go to like different places. There'll just be one. And in fact, for this course, almost no information will be there. The only thing that we're going to use Canvas for is I'm going to put a link to the site I'm going to show you in a second. And Canvas will be where you turn in all your assignments. So there'll be, for each week, there'll be an assignment, and you'll turn in your assignments there. You'll upload them as a zip file. So we'll use it for turning in, and then I'll report grades there, and we'll use it for kind of like the course introduction type stuff. So most of the course will actually be, and I meant to, if Canvas was working, I'd have a link for this, but most of the course is actually up here on a website called GitHub. GitHub is a website for sharing code. So I put the course content up there on GitHub. GitHub's free to use as long as you make your code public. So you can't have private repositories, but you have to pay for those. So it's what's called a repository, it's a code repository. And usually GitHub is designed to write computer code collaboratively. So you and your friend could be working on the same project, and you could create a GitHub location or GitHub repository, and if you made changes, you could push up your changes, and it would attempt to reconcile those changes and tell you what changes has occurred. So you can go back and look at the history of all your code changes. And later, if you decide, hey, something's broken, you could revert back to a previous version. Now this website, I do have lots of code up here, but there's also some text. Okay. So this is the format of the course here. Oh, by the way, let me just say in case you can't read it, it's github.com/MAPOSSUM, which is my username on GitHub, /SPA. The SPA stands for Spatial Programming and Automation. That's the full title of the course. So, SPA. So github.com/
Spell out your username one more time, Dr. Raven.
MAPOSSUM
Thank you.
/SPA. It's also right here, my username. Spatial Programming and Automation. So that's how you get to the website. And if you put a file on GitHub, you put a file called readme.md, it will throw that file down underneath all of the files that are being shown. So these are all the files that are in this directory. These are actually directories themselves. And if you have a README, it'll display it below. So the README for the main page here is the kind of syllabus. What's the syllabus? It is for this code. So this is the main repository to the USM Spatial Programming course. It's a GitHub repo. It'll serve as a location for all the code and all the lecture notes. So this class will meet technically. I think what we'll usually do is we'll meet for about 2 hours, so it's 2 50-minute periods, and then we'll take a break. So we'll probably take a break at about 2:40. Let's see, no, 2:40. And then we'll start up at about 3 o'clock doing the lab. Now, for this course, the lecture and the lab material, I think, flow together a lot more than lots of my other courses. Sometimes the end of the lecture will just be kind of starting to talk about the lab and how to do the lab. So in any case, though, we'll probably take a break because we're going to be here this is a 4-hour class, so we're going to be here for, I think the schedule says something like 6-something p.m., but in practice, although I may still be here to help you work on stuff, I'll stop talking most of the time. By the latest, what would that be? 3, 4, 5? By about 5. Okay, and so technically, a lab class has 2 hours of formal instruction and 2 hours of informal work. So. So yeah. All right. So I'll be there. We'll be. So most of the time in practice, we'll probably end around 4:30, and then there'll be a couple of. Then I'll be here answering questions for as long as you need. All right. So we're meeting here in 229 and on the coast. I know that we have the software we need at least for today on all these machines. I will have to make sure that we have all the software that we need as we progress on into the course. This is a GIS course. We do have software available. I know most of you have had that experience. We have the GIS software that we can install on anybody's computer. So if you need a new download code, let me know, and we can get you the ArcGIS for you to download. That's what we're going to use for the course, is ArcGIS, specifically ArcGIS 10. They just released 6. We're not going to use 6 because they just released it, but it doesn't matter. We're going to use 4, 5, 3. I think whatever we have on these computers, what we're going to use. We're not going to get into many of the differences of detail. So the labs themselves will be posted on Canvas, but that's only when you turn it in. So if there are multiple, like today's lab requires multiple submissions, You zip them together and upload. Okay? All right. So, so this course is going to talk about GIS automation. What's automation? Well, automation is being able to take a process and kind of put it together so that it runs fast. And also you can be able to do similar things all over and over again. Okay, so that's one of the things that we're going to talk about. It's one of the reasons for doing programming is automation. Another reason for doing programming is to couple ArcGIS with other software, and that's one of the strengths actually that of Python, the programming language Python, is that Python has lots of different tools that different people have written to do different things. So they could be statistical analysis, they could be image analysis, they could be, more, well, even just raster analysis itself is really kind of like image analysis. But there's Python tools for doing all these different things. And then there's also other software that people like to use for analysis. And coupling is being able to combine those seamlessly. In other words, being able to execute a single set of instructions for the computer, and those instructions can use some GIS operations and some non-GIS operations to complete a task. And really, this is the magic or the method behind lots of websites that use geographic information. And in fact, some of them are powered by ESRI, some of them are powered by open source libraries. But if you go onto a website and you click, it asks you to click, and it returns all of the people that live within 1,000 feet, and it tells you the average age of those people. If you did something like that, where in the background it's doing spatial information, the magic or the code that's running is code that sits on a server that basically couples and combines the web and processes there with a GIS or a spatial analysis, and returns that result back to be used. For this course, we're not going to be building websites or anything. We do have another course that talks a little bit more about that. But you will learn the processes that you would need to do in order to write kind of like the back end part, the analysis part. All right. So that's automation and coupling. So we're going to focus on the extension of GIS through programming, as well as the development of algorithms for spatial analysis, information extraction. We're going to talk about both vector and raster data. Okay, kind of a wide breadth. One of the things that you should know is lab lecture. I have to put that later on. But one of the things is that this course definitely requires that you've already taken the GIS course. Okay, so in the past I've allowed, and I'll continue to allow, like let's say you're in GHY 217 this semester, like concurrently enrolled, but you should at least do that. It'd be more ideal if you'd already taken it. Ideally, you should have already taken or even taken the second level course, but either be in it or taking it. But we're not really going to be using any GIS knowledge for the first couple weeks, so you have time to catch up. If you've never taken a GIS course and you really want to take the course, I could provide some some short courses or whatnot to take. But hopefully you've done that. All right. Now we've had this course. We've taught this course for probably about 4 years now. It's been 4 years. We added it to when we updated the GIT curriculum. We had this course. So we've had it for a little while, and originally what we wanted to do was make this course, make a prerequisite for this course the computer science course, but that's not the case. Okay, it probably will have helped you if you've taken the computer science course, but that's technically not a prerequisite. So we are going to start from the beginning. On that note, the book or the thing that we're going to work from, particularly for the first 4 or 5 weeks of the semester, is a course called Think Python: How to Think Like a Computer Scientist. That's the book, and it's a free book. I actually toyed this semester with getting a non-free book, but I stuck with it because I think it does pretty well. So this is the book right here, How to Think Like a Computer Scientist. It's really not a book about thinking. It's a book about Python, and it teaches how to code in Python. But along the way, kind of helps you to understand how a computer works, and that's some necessary information. So I would encourage you for the first 5 weeks of the course, 4 or 5 weeks. Let me look at the schedule here, to read along. Okay, it's not extremely difficult reading, and it will benefit you a lot later on in the course. Now, I have 2 other links here. These are kind of like optional links: Python documentation and helpful Python course from Google that you can look through. Now, once we start using Python with ArcGIS, the help is pretty fantastic. But ESRI has written that help. So the part for combining Python with ArcGIS is pretty well. It's pretty good. But before that, the help's kind of scattered. Okay, you gotta spend some time digging around on the internet. Here's the Python documentation. We're actually going to be using Python 2.7. So if you do go to that link, make sure you click on that. Now you might be thinking, why are we using Python 2.7? That sounds like forever ago compared to 3.6, right? Well, eventually ESRI will change, but for now, ESRI is still using ArcGIS, Python 2.7 to automate their tasks. So to combine it with ArcGIS, we need to use 2.7. So the difference between Python 2 and Python 3 is not huge, but it's significant enough that it totally breaks compatibility. It's a totally different package. So there's some syntax that is completely different, but it's very small, but it's enough that ESRI had invested so much in the programming language that it's been slow to change to 3.6. There's a few places in the book where they will point out the differences. And an encouraging thing to note is that ArcGIS Pro, it's a new software package that they created last year, and they're just about to release the second version of ArcGIS Pro. That does use Python 3, and not Python 2. Okay, but not all of the functionality of ArcGIS is currently in ArcGIS Pro yet. But I don't know everything, but it seems to me that basically they're trying to just make ArcGIS Pro have all the functionality of what they call ArcGIS Desktop. And once they do that, maybe they'll just sunset it, and we'll all just move on to ArcGIS Pro. Okay? But I don't know. Maybe they're continuing to develop them right now. Like I said, they just released a new version of ArcGIS Desktop. So for now, they kind of have two products. ArcGIS Desktop, which has all the functionality, uses Python 2.7. That's why we're using Python 2.7. Okay. But the differences are so minor that you'll be able to easily make the transition, but they're major enough that your programs won't run unless you make the changes. So that's why we're going to work with the version of the software that runs with ArcGIS Desktop, which is 2.7. Okay. All right. Python itself is free. Okay. It's open source. It's free to use, to consume. You can download it and put it on your computer without putting ArcGIS on. Now, if you install ArcGIS, Python installs as part of ArcGIS. Okay, and it puts it in a directory. I just opened up two of them because I was impatient. C. Usually puts it right in C Python 2.7. Now you'll notice that I have two different versions of Python installed. If you do two, it's not a big deal. You just have to know which one's connected to ArcGIS. It's probably the one you installed last. And one just runs in 64-bit mode. One runs in 32-bit mode. So if your computer's capable of 64, then that's what I did. So I installed the 32-bit first and the 64 second, which is fine. All right. So this is a mixed graduate-undergraduate class. Regardless of whether or not you're a graduate or undergraduate, there is a project. Now the project itself will be different in scope. We'll go through that later on. It'll be different in scope if you're undergraduate versus graduate, and that reflects the fact that it has a little bit different emphasis on your grade. So this project involves writing some code, and the paper describes the code that you wrote. So the paper is less involved for the undergraduate students, basically. Right? And then there are two tests. Now the first test I'm actually not going to be here for, which is on March 8th, and so I've noted that the test may be take-home. I haven't decided yet. That's what I wrote, maybe a take-home test, because this is a coding class, so it may just be coding. All right. So this is the schedule. You notice that actually 1, 2, 3, 4, 5. It is 5 weeks. First 5 weeks of the course through the middle of February. We are going to not be doing too much with GIS. Okay, we're going to be learning the basics of Python. If you're an excellent Python coder, then you should be thoroughly bored, I guess, for the first 5 weeks. But I don't know if that applies to anyone here. But we will get on to more interesting things if that's the case for you later in the semester. So this is like a quarter of the course is on this. So well over half of the course we'll be applying it to GIS. And you never know, you could learn something in the first 5 weeks that you didn't know before. And anyway, so it's good. We're going to talk about creating your own script toolboxes, and then we'll spend a couple of weeks exploring vector data and a couple of weeks exploring raster data, and then finally we're going to talk about combining GIS with other programs for the last week there. Okay, so that's the schedule. So for each class period, you can go in. So M1, I just called it M1 because it stands for meeting 1. And I did expand the schedule a bit. It used to only be the first 4 weeks of the course we did Python. I added 1 week at the beginning of the course because it does seem like we need to go a little slower at the beginning. So right now, M1 is right, M2 is right, but M3 is where I started splitting them up. So if you go to M3, it'll be a little bit different once I actually update it for this time that I taught it. So you can see here that I made some updates for 2018, but this code right here, this demo1.py and the example1.py, those are from today's lecture, and I wrote those back in 2016. And I'll probably leave those up, but I'll put some more examples. Usually we try to teach this course once a year, but we've been understaffed, so it's been 2 years since I taught this course. All right. Looking at this outline, I've already done the course format, the syllabus. I've already done that. I actually haven't talked about what scripting was. Okay, so let's talk about Let's talk about that that first here, really quickly. So one of the things I'm going to do is I'm going to open up this. I hit the Windows key. That's how I like to open things. And I type in IDLE. All right, and when I do that and I press enter, I get what we call the Python shell. It's fine if you want to follow along right now. So if you want to pull this up, that's cool. Hopefully that's worked for everybody. And if you have the Python shell, you're good. It should be flashing right here. This is what we call the Python, already call it the Python shell, but it's a Python interpreter. Okay, it will read Python statements and execute them. In fact, at this little triple chevron, I don't know, greater than signs, you can type in a valid Python sentence, and it will try to interpret what you're asking or what you're saying. So Python understands math. Okay, so we could start off by just going 5 plus 5, and it's gonna read that statement, and it will give us 10. Or 10 is the answer to 5 plus 5. And so what's happened is that it read that statement in, and it evaluated it, and it showed us the results. Okay, we can enter any sort of valid statement into this. Lots of different math. 7 times 7. So multiplication uses the asterisk, and the answer here will be 49, obviously. Okay. We can do division. 7 divided by 2. Oh, okay. Well, what happened there when I did 7 divided by 2?
Truncate?
Yeah. Right. Yeah, it doesn't do the remainder. We'll talk about why in a second. Okay, but it didn't do the remainder. Incidentally, well, actually, let's just talk about why right now. 7.0 divided by 2.0 will actually give me the proper mathematical operation. All right, so this, I'm getting a little bit ahead of where I wanted to because I want to talk about what scripting is first. But let me talk about this real quick since I brought it up. So there's two concepts here that I'd like to introduce. One of them is called a variable. A variable is something that you want the computer to store, to hold on to, okay, to remember. And although we didn't explicitly make these variables, we just said they were things, it actually stored those in the computer and then did the math operation on it and gave us the result. Okay? All right, so a variable is one thing. A data type is another concept that you need to learn about for this. A data type is a let's see, what's a good definition? A data type is, it's hard for me to say, it's a type of data. But a data type is a, when you store the variable in the computer's memory, it has to know what are valid operations it can do with that thing, okay? So it needs to know if it's, what type of thing it is. So data type is the type of thing that the variable is. So in this case, when I said 7, Python, not every computer programming language is like this, but Python, it dynamically types your information if you don't explicitly state what type it is. So if I type in the number 7 and I press enter, it'll say that's 7. And it says that it is an integer. It stores it as an integer. In some computer programming languages, you have to declare this is an integer. Python, you don't have to do that. Some strengths, some weaknesses, right? You don't have to spend time declaring variables, but you do have to know how Python's going to treat certain variables. So if I type in 7.0, it's actually storing that as what we call a floating point number. Okay, so it's a different data type. So data types. By the end of today, we're going to do basically 3 different types of data types. We've got floating point numbers, we got which means it has a decimal. We've got integers, and we've got strings.
Dr. Raver,
Yeah.
does Python distinguish between float and double as data types?
By default, everything's a double. You could make it a float, but yeah. So the answer is not really. I mean, you could specify a level of precision, but not like it's not like other programming languages in that way.
Okay.
So the last one is strings, and strings are just words, characters. Actually, characters lined up. So there is a difference between this and this. That has quotes around it. All right? So variables that have quotes around them are strings. And Python doesn't care whether you use single or double quotes. That's something that's a little bit hard for people to get around their heads. Do I use single or double quotes? Python doesn't really care as long as you're consistent. So if you start with a double quote, you have to finish with a double quote. If you start with a single quote, you have to finish with a single quote. This allows you to store quotes inside of strings fairly easily. So if you wanted to say George's hat, you could start with a double quote and write George, single quote, S, space, hat, double quote. And the string would be George's hat with the apostrophe in there. Okay? But if I wanted to store a string that said, he said, go to the park, then I can start with a single quote and put double quotes in the string and finish with a single quote, and the double quotes would be inside of the value. Okay? So you can use them interchangeably when they suit your needs. In GIS, we're going to have that problem. Why? When do we use quotes in GIS? Write a query. Remember writing queries in ArcGIS? Well, we're going to be able to programmatically write queries to our shape files. And if we want to say state equals California, then the whole thing needs to be in double quotes, but California will need to be in single quotes because that's the way it goes. Okay, so hold on to that piece of information. We'll definitely demonstrate that that later. All right, let's rewind a bit to what scripting is. So scripting is programming, but scripting is writing programs for an interpreted language. The book gets into a little bit more detail here, but I'll tell you what you need to know. All right, so we could type in a bunch of information and press enter each time, right? But that seems like it would take too long. So we can go in here and go to File, New File, and now we have a window where we can type in a bunch of commands, a bunch of lines of code, and it will interpret one after another rather than just one at a time. So this interprets one line at a time. This allows us to type up a program. A program is a set of instructions that we're going to give to the computer at the same time. And they're all going to run at the same time. That's what a program is. I spilled some stuff on myself. All right. Okay, so we haven't actually, now I'm going to get to where I wanted to get to. So we talked about variables. We haven't actually demonstrated any. Okay. So a variable holds something. So if I say x equals 7.0, then now I have a variable. That variable is x. So if I type in x, it evaluates x and gives me the value that's there.
Is that a single equal?
Yes, it's a single equal. And that's, some computer programming languages do what I just did, which is called assignment. The same way they test whether or not something is actually equal to something else. Okay? So Adam just asked if it's a single equals. If I put x equals 7.0, this is a this is actually a expression the same way this is an expression. Or an operation. We're actually asking, is x equal to 7? This one is saying x is going to store the value 7. So now if I press enter here, I get a true, which by the way is another data type. I forgot. I said numbers, integers, floats, and strings. Forgot about Boolean. Boolean is another data type. So true and false is another data type. By the end of the semester, we're going to talk about all different sorts of data types. Okay? But those are the 4 we need today. So x equals 7 is assignment. X equals 7 is we're inquiring. We're testing. Does it equal 7? Here we're declaring that x does equal 7. And then here we're testing. Does x equal 7? So if we change this to x equals 9, we could say false. And if we then ask for x again, it's still 7. We didn't change it. But if we change x to 9, now x will equal 9. So that's another thing about Python is that anytime we set a variable equal to something else, it basically gets rid of the old thing, what used to be there, changes it. X is no longer 7, it's 9 now. So if you change it, it's going to change it. All right. Okay, so in either case, here or here, when we actually execute, whether we press enter here or we execute the full program over here, it runs our program, or it runs our it runs our commands. It evaluates our statements in what we call the Python interpreter. Now, any computer can have a Python interpreter. It does work across platform. You can install it on Mac, you can install it on PC, you can install it on Linux. And so, in fact, Python is actually installed by default on most Linux distributions. And so, when you run it, it's actually opening up a program that interprets it. Sometimes it's referred to as a virtual machine. So this program opens, reads your code, runs it, and executes your code, and gives you the results if you have a result. Okay, that's a little different than the way programs sometimes run. So in Windows, we've all seen .exe files, right? ArcGIS actually has a .exe that runs when you open it. Those are what we call compiled programs. Okay, they don't need an interpreter to run. They were compiled, which means that they had a program similar to an interpreter that was on somebody's machine, but when they said compile this code, it took the code and read it and changed all that code so that it could run on any machine. It changed that code into machine level code, a bunch of zeros and ones. Zeros and ones. Okay? So Python doesn't. There are ways around it, but we're not going to do it. Python's a programming language that requires that you install the Python interpreter on all your machines. Once you do, the Python interpreter handles turning that code into instructions the machine will need every time it runs. Okay? Now, Python does create a little compiled version to speed things up, and you'll notice sometimes you'll see a .py file. When you create a Python program, it'll be .py. Sometimes you'll see a .pyc. And what that means is that the computer, the Python interpreter has created a compiled version, but it'll still only run on interpreted with the interpreter. So if somebody else wants to run it, they need to have Python installed on their machine. Java, the programming language Java, is kind of similar, okay, in that it also has a virtual machine. Java doesn't compile things to virtual code, to machine code either. It compiles things to run, and you have to have the Java runtime installed on your computer. I don't know if you've ever tried to download some program and it said you need to install Java. Okay, well, it's a little more complex in what you need to set up, but it's very similar to Python, where you just basically need to have Python on your computer to run a Python program. You need to have Java on your computer to run a Java program. But a language like C++ usually compiles to an executable, and you don't need to have C++ on your computer anymore at that point. It'll just run on any computer. But it'll only run on that type of computer. That's the disadvantage. So if you write a program in C++, you have to compile it to run on Windows, Mac, Linux, whatever. Whereas an interpreted program, you install the software, and then your program will now run on any computer, whether it's a Linux, a Mac. Now, obviously, if it's trying to do something that's Windows specific in the program, it's not going to work. But if it's not, it'll work just fine. Okay. All right, let's write a little program inside of this window here. Okay, so this is our window. By the way, there are other ways to get Python to work. Actually, this is just the default one that comes with it, so we use it most of the time. But you can write Python code in different text editors, or there's one that I used called PyCharm, but there's lots of them out there. But this is the one we use for the course. Unless you want to investigate some other one. All right, so I could do something like, let's say I want to just add two numbers together. I could say x equals 6, y equals 7, and then I could say x plus y. And then I'm going to save that.
Dr. Rader, is Python, does it recognize spaces, or does spacing matter?
I mean, it depends on the context. Here, the spacing does not matter in this case. I just did it for readability. However, Python is case sensitive. Okay, so if I put a capital X here and I put a lowercase x there, it won't run. So Python is case sensitive. All right, I'm going to save this right now into C temp right there. I'll just call this, actually I'm going to make a new folder called SPA, and then in there I'm going to call this EX1. Now, I've told people before in classes, I don't like to put spaces in my file names. I don't think it matters, but it can once you start executing your Python code from ArcGIS toolboxes. It can cause problems. So I like to stay away from it. So now I've saved it. So I just typed that up and I saved it to a location. It really doesn't matter where you save it, but you do have to save it before you run it for some reason. Okay. And then I can go run. What do you think the result's going to be? What do you think is going to be printed when I run that? That's what you expect, right? But nothing happens. Yeah, okay. Nothing happens. So if you want to get a result, you always have to write print. P-R-I-N-T. Then you can just save it again. File, save. And you can run it again. So now it will say 13. That's 6 plus 7 is 13. So I could make all sorts of problems. Like I could just forget to put y. Now it's not even going to run. Okay? All right? So one of the big problems, or one of the things that we'll have to do a lot in this class, is what we call debugging. Okay? There can be lots of different errors that we make. This is called a syntax error. Most syntax errors will cause your program not to even run. And it'll probably be pretty good at describing the issue for a syntax error. So it highlights this and says, that's not valid syntax. X plus what? Okay, it doesn't know what to add it to. And so I need to put that back in there. Okay, that's a syntax error. Syntax errors, when they happen, it's because the interpreter doesn't, I mean, it's a language. The interpreter says, I can't read that line. I don't know what it says. Okay, the interpreter gets to that point and it won't run, so you won't see a result. Okay. There are things where it will run, but it won't actually work. Let's try this. Okay. All right. What's wrong with that statement? Right, you can't divide something by 0. Mathematically, it doesn't work. Okay? Your calculator will do E, right? Python's no different. It knows that you can't divide by 0. However, it can read all these statements, right? It can read this statement, it can read that statement, it can read this statement. It knows what they all mean, so it'll actually attempt to run, and it'll run through, but you'll get an error over here. So this is different. So syntax error, you get an error in your program, okay? But what we call a runtime error is an error that happens after you go to execute the program, meaning that all of your syntax can be read, it just can't be understood when it went to actually run that line. It says, I'm a little confused. Can't divide by 0. Okay? There'll be all sorts of bugs that show up in this class when we start writing programs. We're going to get things like this that happen a lot. Okay? Like let's say in ArcGIS, if you want to do an intersect between two GIS layers, so you put the command in to do an intersect, and you get a runtime error that says data set blah 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 does not exist or is invalid. What do you suppose that would mean? That's actually one of the errors. What's that? Yeah. So the data sets may not even work. But another thing, what I was trying to get at is, you may have specified the location where you thought it was, but either ArcGIS isn't reading that as the right location. Okay, that's another reason why I hate spaces in file names, because sometimes if you don't put a quote around it, it won't put the space right. Anyway, so it can't find one of your files. That's another type of a runtime error. If it can't find a file, or if it can't find a variable, like let's just say I said x divided by z. Now if I try to run that, it's going to give me a different error. Z is not defined. This actually happens a lot in Python because we don't have to declare variables. So sometimes we'll use a variable name and we'll forget that that variable name was different. And in fact, this is what would have happened with Adam's question. Earlier I said it's case sensitive. You'd be like, y is not defined. I defined it right there. Well, it doesn't say Python's case sensitive in the results. It just says y is not defined. And what you need to know is that you need to compare those two. Those aren't equal. One is in lowercase y, one's in uppercase y, and so you can't get along with that. All right. Now the third type of error that the book points out, it's called the semantic error, and basically that's the type of error you won't see anything in the interpreter window as a result. The program will run just fine, but you will have done something wrong in either your logic, or you thought it was accessing these files, but it's accessing those files. It's the kind of error that it's kind of the hardest to track down. The book says it runs successfully, it won't generate any error messages, but it won't do the right thing. Okay, that happens all the time in GIS. We'll have made a logical mistake, and although the computer will work just fine, it won't produce the result you want. For example, you may have wanted to do an intersect between two layers, and then you might want to do that over and over and over again, but there's something wrong in your command to redo it multiple times, and that would be a problem. It wouldn't work. Okay, so the one nice thing about interpreted language about this, or not the one nice thing about an interpreted language like this is that you can run a program incrementally as you develop it. You can run a program, see if it works, run another program, see if it works again, run it again, and you can test parts of the program. Next week we'll talk a little bit about functions, but it's good to divide your program up into functions that do specific things. This function will combine two data sets in this way. So you test it, you make sure that it works using two small data sets so that it runs really fast. And then you can just set that aside and say, that code works exactly how I thought. So then you can call that function. Okay? We're not going to talk too much about functions, but for example, one function that I could do right now is, functions look like this, where you put in the name of the function, you put a parenthesis, and then a function takes arguments. It may take one argument, it may take two arguments, it may take 5 arguments, it may take 100 arguments. Here's a function, okay, that is taking one argument, and it's going to return the type of that variable. So it's telling us the type is an integer. So that is, that's one function. Yep. Okay, we'll talk about functions a little bit later. But technically, print is a function, but it doesn't work like you expect. You know, when I say print x, there should be a parenthesis around it. And in fact, that's one of the changes in Python 3. So by the way, in Python 3, print, because it is a function, has parentheses, that you put parentheses around what you want to print. Okay? So that's the creators viewed that as kind of like a weird thing. Print's a function, why doesn't it work like every other function? And so they put parentheses around it if you want to. So in Python 3, you would type print x like that. It looks like in Python 2.8 or 2.7.10, they've allowed you to do it Python 3 like. So that's actually good. Okay. All right, now we talked about how Python is a language. Now, a language is something that we use to communicate. And you're going to look at Python and say, I don't talk like that. Well, okay, yeah, you don't talk like that. Because Python is what we call a formal language, not a natural language. We speak what we call a natural language. And in a formal language, the syntax follows strict rules. So we have rules about the syntax. For example, it's case sensitive. Okay, we can't use certain operations. The book says, you know, you can't say 3 with a $sign in the middle. That doesn't work because that's not valid syntax. 3, whereas 3% 3 does actually work. It's called the modulus operator. And it says, okay, what's the remainder when you divide this number into that number? So 3% 4 will give you 3 because 3 would remain. I meant to do this though. Would give you 1. Because 1 would remain if you divided 3 into 4. Okay, so the book uses the term tokens. Tokens are the basic elements of language. So in English, tokens would be words, numbers, chemical elements. So when you're debugging, you might actually have a message. In fact, you will sometimes say such and such is not a valid token. In other words, it's not a valid piece of language. Okay? It can't parse it. Parsing is the process that it uses to interpret. I'll turn that off. Okay. All right, I'll let you read the rest of that on that section. All right, we already wrote a program here, okay? But the book has you write your first program to print "Hello World." So we could just underneath here write print "Hello World." That's the first one the book has. So now, what do you think our program's going to do? Is it still going to execute this stuff? Yeah, it is. So down here, what do you think is going to happen? I'm going to get, well, actually, it's not going to execute that stuff because it's wrong. So let's put it back to the way it was. So now, what will the result be, do you think? It's going to print the result of x divided by y. Of course, that's going to be some number. And it's going to print "Hello World."
What's y equal there, Dr. Raver?
I have it equal to 5.
Right.
So 6 divided by 5 in integer math is 1 because it goes in one time, but there's a remainder, but it doesn't show the remainder. Okay? If we wanted to, let's talk about another function. I'm going to give you a preview for another function because I already brought one up. Okay? Type was one function, but FLOT is another function. This function, notice an IDLE, most internal functions, when it sees it as a function, I'll turn it purple for you. Okay? This function takes any number, or string actually, and converts that value into a floating point number. So it turns x, which was an integer because we declared it, right? We didn't declare it, but we set x equal to 6, and by not including a decimal, we basically made it an integer. Now we're turning them into floats. So they were integers, but we're making them floats. And now if we run this, it's going to give us the floating point answer there, 1.2. Okay? So 6 divided by 5 is 1.2. It goes in 1.2 times.
But it only changes x and y to floats for that one line. It doesn't readjust the original variable, does it?
That's correct. In fact, we could test that by printing the type of x. Oh, I lost the. Somebody turn it off. Reach up. Turn it off. Oh, it stinks if the bulb is burned out. It's on the coast. We're having technical difficulties. It's all right. My light's flashing. I'm going to try to unplug it. Plug it back in and see what happens. That's the first. Oops. That's the first. First rule of computer fixing. Unplug it and plug it back in.
I don't know.
light is turning back on. So while it's coming back up, my computer's still recording, so that you'll see this later. But it did. Now I have a third line, which says 1.2 hello world, and it says type integer. Okay, so we may have to survive on a bluely tinted screen. So I'll tell Cochran or Candace that it's on its way out, it looks like. We're not going to do any graphics today. I'm going to move this one more time. I kind of knocked it. Maybe I shouldn't put solid. Dangerously. It doesn't really fit on there, does it? Okay, there we go.
I don't see that.
It doesn't look as bright as it did before either, does it?
Shut the Zoom.
Maybe that'll help, maybe it won't. Okay, but here, the type is integer still. Now, if we did do something like this, that's a valid statement in Python. We're taking x and we're converting it to a float, and we're taking the result and storing it in x. So it's gonna write over x, and it's going to make it a float. Now we're going to get the same result for the first two on here, but we're going to get a different world thing on the bottom. We've now converted x into a float. Okay, so we took it, we converted it into a float, and we did. There's really no syntax for just converting it in place. Like what we actually did was we went to the computer's memory. We said, hey, we stored x. Give us the value of x. Then we converted it into a float, and then we put it back, and we said, hey, replace x with this value. Now it's a float. And so we did write over it. All right, so that's that was a good question. There's the answer. All right. Now, as far as your assignments for today, your assignments for today are to just do the exercises in the book. However, if we go back here and we go right here, just wanted to highlight that and make sure everybody sees that. So exercise 1, 2, you don't do that. It doesn't work because they changed their website. So like if I say help print like it tells you to do, it gives you a statement. This is what you were supposed to do for 1, 3. So 1, 2, don't do that one. 1, 3, you can do that one. And then 1, 4 is what we've already really done. Okay, but you're going to do another little math problem, and that's it. Okay, so on to chapter 2, which we've actually already discussed a lot of what we want to discuss in chapter 2, because chapter 2 is called Variables, Expressions, and Types. So yep. So we're down into here. Actually, we talked a little, kind of got we're following the book a little bit more, actually. Okay, so we talked about variables and types already. One of the things that's important to note is that there are some words that are reserved that you can't use. There's a list of them in the book for 2.7. There's slightly different rules for Python 3, but you can't say like this, and is equal to 9. Okay, that's a word that's used in Python as an operator, and so it's not available to use as a variable. You can't use any logical constructs like not, or. You can't use other words that are used in the language like for and while. Those are for looping. We'll talk about looping later. Next week we'll introduce those concepts and really talk about them 2 weeks from now. So it's not extremely long list. It looks like it has about, it says 30 words. You can't use those words in there. Add and subtract, multiply and divide. Let's talk about a few others. We talked about the modulus already. That's the the percent. So 9% 4, it's going to give you 1 because it goes in twice with 1 remaining. All right, it's a little more obscure. Here's one that's not so obscure. This one here. 2 asterisks 2 is actually 9 raised to the power of 2. So it's 81. 9 times 9. Okay? That's one. If you ever decide that you need to know how to do a certain operation you know how to do, that's a valid question to ask me or to Google it and find out. So there's lots of different operators that you can do. Just remember that with any operation, it will assume that you want to do integer, that your result should be an integer if either of your inputs are integer. I don't know if it's either. I got to check that here. So let's see, 9 divided by 3.0 is 3.0. Actually, let's use something that doesn't go in is equal. 9 divided by 2.0 is 4.5. Okay, so only one of our values was integer. Let's see if it works the same way. Yeah, okay. So if any of your values are not integer, then it will provide a non-integer result. However, you can't go like this. Right, that's going to give you an error. So if you ever try to add a string, and that goes for this even. If you ever try to add a string to a real number, you're going to get an error. You can use those functions I talked about earlier to convert 9 into a. You can go like this. So that actually converted this 9 into a float. But what if I wrote float pizza plus 9? I won't even type it. What do you think is going to happen? Is it going to give me an error? Yeah, it's going to give me an error. Right, it's going to try to read the word pizza, and it's going to try to convert it into a number, but pizza doesn't, there's no number pizza. I wish I had a lot of pizzas. I'm hungry right now. There's some weird exceptions though. I think the book points them out, so I'll go ahead and point it out real quick. You can actually multiply strings. I gotta spell it right. All right. So if you multiply pizza by 2, you get pizza. Yeah. So there are some exceptions, but typically you can't do mathematical operations with string. You can't mix strings and numbers. I think that's the only exception. You can't divide pizza by 2. At least I don't think so. Nope. Okay. But you can multiply pizza by 2. And that's for like filling out, like if you wanted to fill a whole line with something, you could use that as a shortcut. So like quote, space, 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 all the way, space, 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 quote. One whole line of spaces. If you didn't want to fill it out, you could just put quote, space, quote, times 50, and it would give you 50 spaces. Okay. All right, so it's more of a shortcut thing. Now, you can add together, different programming languages do this differently. You can add together strings. I'm going to put this up here. You can add together strings. That's what we call concatenate. And what it does is it puts the two strings together. Okay, so if it's the first name and the last name and you want it to appear together in a report, you could say A plus B. What if I wanted a space to appear in the middle?
You can do a quote, space, quote.
Yeah, I mean, I can put a space here. I think somebody said that, but that's not as elegant as what I think Adam's trying to say. Is this what you're trying to say?
That's Ian.
Oh, Ian. All right.
He sounds just like.
All right. So I put a space in between there. See that? And we'll get in. We'll talk a little bit more about string formatting because there's other ways to do that. Yes, Brittany. I know that it's not really yellow to me, and it's a problem. It says print A plus quote space quote plus B. A equals hello, B equals pizza. Yeah, I think that bulb's going out. It'll be comforting, but not too comforting for you to know that on the recording it will be restored to its glorious correct colors. They won't be blue. No blue tint. All right, and hopefully it doesn't take them long to replace the bulb when we tell them. So we'll get that fixed. And we're really close. I don't think we're going to go anywhere near to 4 o'clock. We're really close to the end here of what we're going to talk about. So we didn't explicitly say, but each line here is a statement. So that's a statement. A statement is evaluated. It's a unit of code, one line, and all right. So we talked about interactive. This is called interactive mode. This is called script mode. We talked about that. Order of operations is the same. It follows the mathematical rule of precedence, and so it does parentheses, then exponents, then multiplication, then division, then addition, and then subtraction. You don't need to memorize that for anything, but when in doubt, use parentheses. If you want something to happen before something else, use parentheses. If you don't know that it's going to happen before that. We talked about string operations. Okay, 2 more concepts that I want to talk about before we finish today. One of them that actually gets brought up later, but I'm going to bring it up now, is import math. So Python actually has a lot of functionality built in, but some of the functionality is only exposed if you bring in additional resources, okay? And there's lots of math functionality that's available in this thing. It's called a module, okay? We're gonna, all the interactions with ArcGIS are a module too, okay? But math is a simple module that allows us to do mathematical operations. And it also stores a bunch of mathematical constants for us. So I just think that it's good to bring up this math module here because it kind of fulfills. Somebody might ask the question, how do you do a square root? Well, there's no function like you can't go double exponent means double asterisk means exponent. Double divide doesn't mean square root, or doesn't mean root. Okay. So
You could do asterisk asterisk 1/2.
you could. Good job. Okay. Exactly. Good job. That actually would work. All right. So math, but you can do math.sqrt. Okay. So we're going to introduce a few concepts that we'll hit later more. Okay. But math is a module, and it has like a bunch of functions inside of it. And the way that you access all of those functions that it has is you put a dot in the middle. So math is a thing, and you say dot, and you can get any of its functions by just typing math.sqrt. And so I'm going to take the square root of 9 and see what that is. We all know what that is, but now when I run this, I get 3.0 because that's the square root of 9. And notice that inside of that function, it returned, it did the conversion and is returning a floating point number. It's a little different than some of the other things we've done so far. Okay. Another thing that you could do is you can get some constants. So if you ever needed like pi, for example, pi is stored in the math module as a constant. So it'll actually print out pi out to the level of precision for a floating point number. Right there. Okay. So, and then also you can help math. And it'll show you all of the functions that are in there. So, for example, was it Adam or Ian that pointed out you could do asterisk asterisk 1/2?
That was Ian.
Okay, so you could do that, but and I'm sure there are other ways to get the tangent and the square root. The tangent and the sine. But there's a bunch of mathematical functions in here that are shorter than trying to type them all out of there. So that's another. This is just basically a module is a collection of functions and values for you to use. So later when we get into ArcGIS, there's a ArcGIS function for taking two data sets and doing an intersect. And so we just have to call the module. By the way, the module is called ArcPy. Say ArcPy dot and then the name of the function, which is kind of long, but let's just say it's called intersect for now. Intersect, and then we put in the two files, one intersect, and the result that we get back is an intersected data set. So looking on to next week, functions sometimes return things and sometimes they don't. Okay, we'll talk about that more. Next week. Okay, the other thing that I want to talk about is my code's already getting pretty ugly over here. Okay, it's already getting pretty ugly. I don't understand what the heck's going on, probably because I wouldn't have a goal. That's one of the things about a program is that you program with a purpose in mind. Okay, I'm sure you've heard the term algorithm. Okay, an algorithm is just some people think, well, is that like math? And that's logarithm. An algorithm is just a process for performing a task. So you're taking an algorithm and you're putting it into code. So that's what programming is. You want to find a process. So the first step is always to think about what you want to do, and then break what you want to do into steps. If I want to get from point A to point B, what are the steps I need to do? I need to take these steps. Then convert those steps into Python language. Okay? So both of those tasks are sometimes difficult. Okay? Finding out the steps I need to take and programming in Python. I actually think that A is oftentimes harder than B, the finding out the steps you need to take. And I think a lot of people that get frustrated with this course, they think, I can never figure out how to do this in Python. That's kind of secondary, especially once we start getting into GIS. It's better to think about how we're going to do it. So some of the times, we're going to spend a lot of the time in class discussing how we do it in GIS, and then we'll start converting it into Python, and you guys can finish that up in the lab. Okay? So yeah. So when we write a program, we're going to have a goal. We've got to break it down into steps. We're going to find out how to do it, and then write the Python code to do it. Sometimes what helps is the concept I'm getting to here, which is a really simple concept called comments. Sometimes what helps is to kind of make comments before you even write the code that goes there. And make comments are things that are not executed. So if I was to write my code here, by the way, a comment is made with a hashtag. We used to call them pound signs. I don't know why really, but there's another word for them. But anyway, you put one of those down and you say, get two numbers, convert x into a float so that the result will be a float. So you see what I'm doing? I'm kind of like explaining what's going on. And then print print the quote. I'm a horrible speller. Right? I'm not a good speller. I can spell product. There you go. So then I print the product there, the product of these two numbers, and then I can continue on putting lines of code in. When I go to run this code, I'm going to run this code here. Nothing different happens. It runs the exact same way that it ran previously, with no changes. The comments aren't for the result. The comments are only for you and for anybody else that's going to look at your code and run it. So comments are helpful. They particularly help you to develop your code. And sometimes you can put in a comment here that says, make print hello pizza again. I don't know why you want to do that. Pizza have another eye? Okay, so then you could put that next line. You could leave that thing, but you're basically making a comment so you can add more information later. You can add more to your code later. So sometimes it starts out by you just writing a bunch of comments and then you filling in those sections in order to complete a task. All right. Oh, one thing that I didn't talk about that the book talks about is something called the state diagram. And a state diagram is just a diagram that shows what values you think are being stored in your different variables. And your variables can change. In fact, right here we have a change that occurs. We're taking x, we're changing it, and we're putting it back in. Okay. So you need to remember that Python does that. Okay. Well, I think that we did those. Rather, this is about the time. It's a few minutes short of when we would take a break. Let's rather than take a break, let's just look at the exercises and talk about how we could do those, and then we could just adjourn for the day. And I'll be here in case anybody has questions about what you need to do here. So under exercise 2.2, okay, assume that we execute the following statements. For each of the following expressions, write the value of the expression and then type the value of the expression. You can go ahead and do that in Python. Okay, width divided by 2 is going to give you a value. And we should be able to know by now. Just remember that 17 divided by 2 is not going to give you. It's going to give you an integer. It's not going to give you a floating point. Width divided by 2.0 will give you a floating point. Those are the expressions. Okay, and then finally in 2.3, you're going to be using Python as a calculator. And one reason why I showed you the math module is that it makes these sorts of things a little bit easier with like pi. Okay, let's see what else it says. All right, I think that's good. Anybody have any questions so far? So what I would typically do is to read the chapter ahead. So although we're at now a little bit early today, what you should do is go ahead and read chapters 1 and 2, but then also read ahead for next week, so you'll always be ahead. Go ahead and read chapters 3, 4, and I think I might have made a mistake. Let me see. Yeah, no, that's right. 4, 5, and 3, 4, and 5 for next week. All right, and then I'll go ahead and tell you when you read 3, 4, and 5, and when it talks about recursion. That's an interesting topic. We aren't going to use recursion a whole lot, so if that part gives you a headache, just move on. We're going to use iteration a lot more than recursion. They're both ways of doing something over and over and over again. All right. Any questions? I'm sorry, what? Okay, so if you were you able to get to this web page? So this web page is mathawesome.sba, and then there's a link. The above is a free textbook. There's a link right here. It's pretty long, so I think that's the best way to get to it. Is go to this web page. You can Google. I'm pretty sure it'll show up. he has written an updated version. And so make sure you're not getting the 3 version because we're going to use 2. Okay, there's not a whole lot of differences, but here it is, if I Googled it. So he has a new version of the book. If you're using Python 3, you might want to use the 2nd edition. So the 1st edition, which was written in 2014, is the book we want. And then the 2nd edition, which was written this year, or last year, 2017, that's not the book we're using. Although there's not a whole lot of changes, like I said. All right, did I help? And then eventually, all these links will be, so now I don't have any courses in there. Yeah, now I only have 1 course in there. None of my other courses show up.
Dr. Rayburn,
Oh, maybe I have to hit all courses. Yeah.
so these early ones, we're not going to email these to you, if you don't want to see these?
For today's, next week though you'll have some that you'll email to me. For today's, there's nothing to turn in, and I don't have them put up. That's correct. But starting next week, we will follow the book, but there will be exercises to actually turn in. There it is, right there.
Have you want those that day or by the next meeting?
I'm sorry. What's that?
When the lab assignments are due,
Oh.
they due that day or you want
No.
it by the next meeting?
They'll be due by the next meeting after that, the lab assignment.
Okay.
So how do you publish this? Because it's not published. See that? I did publish it before. Before publishing, you guys need to publish a module. Okay, maybe that's why it unpublished. Okay, so it looks like it's my fault. I have to create a module and then hit publish. We never had to do that before. So I'll do that today, and I'll put up on this webpage. There won't be a whole lot, but if you go under syllabus, I'll have a link to the GitHub account. In fact, I'll put that on the home page too. I'll put a link to the GitHub account, and I'll put a link to the book there too. And then under modules, every week there'll be a lab, except for this week, for you to actually turn in. Okay? All right. Any other questions?
So your videos